Hello guys, welcome back. This is the second video, application problems of quadratic equations. So again, last video we saw that a quadratic equation has an x squared in it. There is always two answers to this. And there are three ways to solve these things, and one of those ways is factoring. Factoring is the most common, and probably the next most common is going to be the quadratic formula. I will, however, require you to do completing the square, but those two are the two most important ones, in my opinion, when it comes to application problems. Again, I hope you're staying warm out there. It's a little chilly. The first application problem deals with, I guess, numbers. So the sum of two numbers is 23, and their product is 132. Find the two numbers. Okay, and this kind of goes back a little bit to Unit 1, I guess. So when we talked about keywords, so when we were writing things, the sum of two numbers. So if you were to write the sum of two numbers, that is adding. Product, as far as product, the product of two numbers is 132. Well, the problem is when you have two equations and two variables, that's a problem. So you have to get an equation with one variable to solve. Well, if I take this top equation and I solve for y, so what that means is get y by itself, then I end up with y equals 23 minus x when you subtract x from both sides. Now what's going to happen is I'm going to take that 23 minus x and put it into that y of the second equation. So technically this is called substitution, and that's exactly what this is. So 23 minus x. Okay, so if I take a look at this equation, it does have multiplication in it, or the distributive property. So x times 23 is 23x. X times negative x is negative x squared. Notice the x squared. The x squared makes this a quadratic equation, which makes this chapter. So the rule for x squared is to set this up so that it looks like a trinomial and that it equals 0. So a couple things. This x squared here is negative. I would rather that be positive. So I am going to move it to the right. I'm going to move the 23x also to the right. And then the 132 is going to stay over there. So I'm moving both of these terms to the right. That way they would change signs and my 0 would be on the left. Regardless of the 0, it doesn't matter if it's on the left or the right. So if it bothers you, go for it. You can rewrite this and have it on the left. But the bottom line is once you see the 0, then you should be able to factor this. If you can't factor, then you would have to use the quadratic formula. But most of the ones I give you, you will be able to factor. So please make sure you can factor trinomials. Now, the only problem is with a quadratic equation in an application is the factoring gets a little big. So 132, you kind of have to sit down and really look at the multiples of 132 that add together to give you 23. And again, that may take you some time to figure that out. And it is 12 times 11. So 12 times 11 gives me 132, but 12 plus 11 gives me the 23 that I need. So I do need negative 12 and negative 11 because I got to make the negative 23. Again, typical quadratic equation. You have your two pieces. You set them equal to 0. And if you work backwards, you get x equals 12 and you get x equals 11. And that is the mathematical way to find those two numbers. So if you took those two numbers, they should add together to give you 23. And again, they should multiply to give you 132. And mathematically, that's how to do that. Now, you probably could sit there and try to reason and try to figure it out. But I do want you to be able to show that mathematically, because that practices our quadratic equations, it practices our factoring, it practices all of that. So I do want you to do that. So the first problem on the next quiz is one of those. So I do want you to actually set it up, and I want you to solve using that method. Okay, the second application problem I have for you is an area problem. So if the area of the rectangle is 22 feet squared, and the length is 3x plus 1, and the width is 2x plus 1, solve for x, and then find the length and width. Okay, so if I drew a picture here, the area of the rectangle is 22 feet squared. I always usually write my area in the center. The length is 3x plus 1, and the width is 2x plus 1. So if I take a look at that, we do need a formula for the area of a rectangle, and the formula for area of a rectangle is length times width. So if I take a look at this formula and I substitute, area is going to be 22, and length times width is 3x plus 1 times 2x plus 1. If I look at that, how do I take 2x plus 1 times 3x plus 1? Because this is not equal to 0 yet. There's no 0 here. You have to get a 0 there. So you do need to FOIL. So that is 6x squared plus 3x plus 2x plus 1. And of course, that equals 22. And what I'm going to do is subtract. I'm going to combine like terms here, but I am going to subtract 22 from both sides as well. So what that sets me up with is my 0. And then I got my 6x squared plus 5x minus 21. And what I'm left with, of course, again, is a trinomial. So there's the trinomial. So there's the trinomial. How do I factor it? This is a harder trinomial. So once again, you are looking at the factors of 6. You got 6 and 1 or 2 and 3 to use. And usually it's going to be the numbers that are close. I'm going to start with the 2 and the 3. And then for 21, I got 7 times 3. So where do I put the 7? Where do I put the 3? So that when I check the outside and the inside, I make a 5x. So if I look at this, I'm seeing if I put the 7 here, I put the 3 here, this is going to make a 14x, and the inside is going to make a 9x. Well, I can get a 5 out of that. So I have to take 14 minus 9, and the 9 would have to be a negative, and the 14 would have to be a positive. So that is the solution that works. If you would FOIL that, that would work. Okay, give you 6x squared plus 5x minus 21. So as far as solving, you take your two pieces again. There they are. Set them equal to 0, and you would solve. Now on the one on the right, which is why I'm doing this one first, you end up with a negative answer. Can your sides of your rectangle be negative? No. So sometimes when you do quadratics, there is actually solutions that don't work, especially in application problems, because negatives usually don't make sense, especially in terms of length or width. So the second one, however, if I add 3 to both sides and divide by 2, I end up with 1.5. So that one is the one that would make sense. X is 1.5. So therefore, if I go back to my rectangle, the width was 2 times 1.5, or 2 times 3 halves, plus 1, which is really 4. So 4 feet. and the length was 3 times 3 halves plus 1, which ends up being, what was that, 4.5 plus 1. So that ends up being 5.5 feet. So as far as finding the x and finding the missing value, that is how you would do that. Of course, you could check if I did multiply the 4 and the 5.5 together, does that give me 22? And it does. So those are the 2 word problems that I'm going to make you responsible for. And again, you could see either one of those kinds. Now, I do want to make a mention. Some of the word problems in the book are get a little bit challenging, especially towards the end. So don't spend too much time in section 1.5, especially I believe it's 77, 78, 85, 91. They get very difficult. So I do have the answers for those. I will give those to you next week if you wanted to try them. But again, remember, I'm just looking for an attempt of the homework. As long as you can do the ones that I did in class or the ones that are on the quiz, you are good for the tests. Okay, so as far as I keep talking about this test, but still we still got a little ways yet. But when you're studying for the test, the single-handedly best thing to study is those quizzes. Make sure you can do every single problem on there. The other thing I would go back and study would be the notes. Okay, and I would make sure I could do one of every kind that is in the notes. Okay, so that does it for part 2. Part 2 is a little shorter. I just wanted to do the application separate. So that will do it for video 2. I will be back for part 3, and I will continue with section 1.6.